So we are discussing the time complexities. So what is time complexity? How to calculate the time complexity for an algorithm? The time complexity, what is time complexity? The amount of time required to execute the program, that's we call as time complexity. So this time complexity includes both compile time as well as execution time. The procedure to calculate the time complexity by using a frequency table. So we are using some table. By using that table, we are calculating the frequency time complexity. So in this table, so the steps for execution indicates whether the statement is executable statement or not. A program will have two types of statements: executable statements and non-executable statements. For example, the declaration statements or the non-executable statements. The both begin and end is a non-executable statements, and some statements are executable statements. If it is executable statements, the steps for execution is 1. If it is a non-executable statement, the steps for execution is 0. Then frequency. Frequency indicates how many times the statement will be executed. 1 time, 2 time, 3 time, like this. How many times the statement will be executed. If some statements are executed 1 time, some statements are executed 2 times. Similarly, some statements are executed n times. Some statements are executed n plus 1 times. Then final the total indicates so again the frequency, so which is in a calculation. Suppose actually the total is used, so we are using inner loops. At that time we will get the complete process. That's why we are using the total. By adding all the total, we get the frequency time complexity. So to find the exact time, this is the exact time complexity for the algorithm. So however, we can avoid the constants. When we are avoid the constants, it goes to nearly n. So the time complexity for the algorithm is, we say that order of n. Actually, that is the exact time complexity is 2n plus 3. So while in the normally we note that where we are removed the constant values 2 and 3, so then it is a time complexity for the algorithm is order of n. So similarly, you go for another example, how to calculate the time complexity for a program. For example, if you take a matrix, matrix addition. So suppose if you take a matrix addition, how to calculate the time complexity, matrix addition. Algorithm, steps for execution, frequency, and total. So we go for algorithm first. All algorithms begins with algorithm. So what is the name of the algorithm? Matrix addition. A matrix addition will receive the 3 inputs, int a of 5. So actually no need of data types, just we write it a of 5, comma b of 5, c of 5. 571 మెంటల్ వచ్చిందా? స్క్రీన్ మీద గీస్తున్నా ఏమ్రా లోఫర్ ఫోన్లు చేసా అంటే ఎత్తి బయట నవ్వుతాను. మాకు ఇదే పని అయింది, నువ్వు గీస్తుంటే స్క్రీన్ క్లియర్ చేయటం. ఎత్తి బయట నవ్వుతా. 571 ఐ విల్ రిమూవ్ యూ. హలో సార్ సార్ అవును సార్ ఇప్పుడు జరుగుతుంది సార్ ఇప్పుడు 2:45 to 3:45 సార్ అవును సార్ అయిపోయి చేయమంటారు సార్ ఆ, ఆ, ఏ ఏం సార్ ఆ, అంటే మనం ఎందుకు చెప్పడం సార్ మనం ఎందుకు చెప్పడం ఆ, ఉమ్, ఆ, 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 అవునవును అవునవును ఆ, అవునవును ఆ, ఆ, ఉమ్, ఆ, 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 మన అది మామూలుగా నాకు తెలిసి వరకు మిమ్మల్ని ఒక మాట అవునా కదా సార్ అని ఒక తీసేసావా ఇంకా మళ్ళీ స్టార్ట్ చేయాలి 571 so why you are drawing on the screen huh so when class is going on you just listen don't draw on the screen if you repeat this concept once again I will remove from the meeting okay so this is the algorithm so in this algorithm we start this start algorithm so we have the statements for I equal to 0 I less than n I plus plus this is the statement another statement is for j equal to 0 j less than n j plus plus c of ij equal to a of ij plus b of ij. So this is the process. This is the algorithm for matrix addition. So then we go for steps for execution. How many times the statement will be executed? This is a declaration statement. So the execution, the steps for execution is 0. This is also a declaration statement. The steps for execution is 0. So this is the declaration statement. The statement, this is how many times, this is a executable statement. So the frequency is 1. This is also executable statement. The frequency is 1. This is also executable statement. The frequency steps for execution is 1. This is 0. Then frequency, how many times? This is 0 time. It's not a executable statement. So this is also 0 times. So how many times this statement is executed? This statement is executed n plus 1 times. This statement is executed n plus 1 times. So this statement is executed how many times? N into n plus 1 times. This statement is executed n into n times. Finally, this is 0. This is 0. This is n plus 1 times. So this is n square plus n times this square. N square time 0 times. Finally, when we add this all this, so when you add all these statements, the total is 2n square 2n square plus 2n plus 1, 2n square plus 2n plus 1, 2n square plus 2n plus 1. So this is the process we are getting the result. So this is the algorithm. Then actually we say when we removed all the constants, so the final the big value is n square. We say that so total complexity equal to order of 2n square plus 2n plus 1. This is the way to calculate the time complexity. So like this for every algorithm. So for any algorithm, so we follow this process. So when we follow this process, we can find the actual constant time complexity. So however, we are neglecting the terms. Some terms actually are constants, and some other terms we can say that order of n square like this. We say exactly which the time complexity is order of n square. So by neglecting the terms 2n plus 1 and 2, that is the process we are using to find the time complexity. Similarly, go for bubble sort. Similarly, go for bubble sort. If you go for bubble sort, this suppose if you go for bubble sort, what is the time complexity? So how to calculate the time complexity for a bubble sort? So if you take one algorithm, bubble sorts, actually, again we'll take table. Algorithm, steps for execution, frequency, and total. So if we go for algorithm, bubble sort, E of 10 n. This is the algorithm. In I comma j comma 10. For example, these are the variables for I equal to 0, I less than n, I plus plus. for j equal to 0, j less than n. If a of j greater than a of j plus 1, temp equal to a of j equal to a of j plus 1, a of j plus 1 equal to temp. So this is the process. So this is the process for a bubble sort. So this is an algorithm for bubble sort actually. So now we'll go for steps for execution. So in steps for execution, we determine whether it is executable statement or not. So actually, the executable statements we for executable statements. So we have the executable statement. So it is a non-executable statement, the 0. It is a non-executable 0. So this is also non-executable 0. This is executable statement, the value is 1. This is also executable statement, the value is 1. This is also executable statement, the value is 1. This is non-executable statement, value is 0. This is executable statement. This is also executable statement. This is non-executable statement. This is non-executable. These are the steps for execution. Steps for execution indicates whether it is executable statement or not. So if it is executable statement, the value for the executable statement is 1. If it is a non-executable statement, the value for non-executable statement is 0. Then we go for frequency. So what is the frequency? So what is the frequency of this? So it is 0, no times actually. This is also 0. This is also 0. So how many times? This is if the loop will be executed n times actually. So in n plus 1, this is the n plus 1 times. This is also n plus 1 times. This is n times. 0. This is n times. So the total, we go for total 0 time, 0 time, 0 time. This is n plus 1 time. Zero times this 0. So sorry, this is n into n plus 1 times, not sorry, n into n plus 1 times, n into n plus 1 times. So n into n plus 1 times. This is also n into n times. So this is n square plus n times, n square plus n. This is n square plus n times. So this is also n square times. N square times. So this is n times we need n 0 times. Finally, the time complexity is total. The total we calculate the total equal to. So how many n squares? 2n square. 2n square. 2n square. 2n square plus 4n. 1, 2, 3, 4, 5n. 5n plus 1. So when we neglect the all remaining terms, so the time complexity is, we say that order of n square. Actually, this is the way time to calculate the time complexity. So when we are neglecting the terms, remaining terms, so then the time complexity is, so we say that when we are neglecting all the constant terms and everything, so we are the time we say that it's a time complexity is order of n square. So we are neglect all the constants 2, 2, 5, n plus 1. So actually we are only consider the longest term. The longest is n square term, that is the time complexity is n square. So in this way we are calculating the time complexity for any algorithm, whatever the algorithm it is. So we are using the same process to find the time complexity. Then we go for what is abstract data type. So what is an abstract data type? What is an abstract data type? An abstract data type so is a data type that is defined by the user, which contains some set of data and operations on data. An abstract data type is a data type is a user defined which contains some set of data and methods which operates on data. So what is an abstract data type? An abstract data type is a data type. So it's a user defined data type. So we'll say that is a data type which contains some set of data. It contains some set of data and methods which operates on data. So some methods we are used to operate on data. It contains some set of data and methods which operates on data. So in C++, in C++, classes will support concept of abstract data. In C++, class is a abstract data type. In C++, class is an abstract data. In C++, class is an abstract data type. So because class will contain the data and methods. So in C++, class will support the data and methods. This is the way we are using in C++ an abstract data type. So class is abstract data type. What is an abstract data type? An abstract data type is a user-defined data type which contains some set of data and the methods which operates on data. So there's some data. So data and methods which contains a data. That's we call as abstract data type. In C++, class is an abstract data type. A class will contains the data and it contains the methods which operates on data. So we have the both classes and objects. For example, if you go for example, class stack. Take one example, class stack. Private E of int s of 10 comma top. So int s of 10 comma top. Public stack top. So stack top equal to, so we are using the top equal to -1, stack top equal to -1. Then we use functions, some functions, void push, void pop, void display. So this is the way. So this is called as an abstract data type. Here stack is an abstract data type which contains the data as often in the top. So we have the constructor stack, stack and push pop are the methods. So an abstract data type will contain some methods. The methods are classified into different ways. So we have these are the methods. The methods are push, pop, and display are the methods. Stack is constructor. So this is the functions of the methods. Abstract data type. The methods of the abstract data type are classified as the methods of abstract data type are classified as, so creator, one is called as creator, so creator, so creator, or we'll call as constructor. Creator or constructor. So the new function, so this which is it to create a new instance of, so, constructor is, what is the purpose it is used to create a new instance of the instance of designated type. So this is a one way, the methods. We have the here stack. Stack is a constructor. So it is constructor. So what is the purpose of constructor? To create a new instance of the designated type. Then another is transformers. Transformers. So what is it? These functions also used to create the instance of the designated genre. It is also used to create a new instance of designated type from one or more instances. So we this is called as transformers. This one is nothing but copy constructors. So we are constructing new instance from existing instances. That's we called as transformers. So which is same as copy constructor. So copy, we know that copy constructor. A copy constructor will we can in C++ where you already know that copy constructor is a constructor which is used to create an object from existing objects. In order to create an object from existing objects, we use transformers. Hello, sir. ఎవరితో సార్ ఇంకా క్లాస్లో ఉన్నా సార్. So another is observers. So we thought type is observers or reporters. So we thought type of methods is observers. These function provides information instance. These functions provides information about an instance. So these are the different methods actually. So this is about abstract data type. What is an abstract data type? So an abstract data type is a data type so which is used an abstract data type is a data type which contains some data and methods. So data methods which operates on data. The methods and which operates on data will call as an abstract data type. So the data types in C++, all the abstract data types so in C++, the class is an abstract data type because a class will contains data and methods. So for example, if you take a stack, one example, class stack. So stack is a class. So we have the member data s of 10 and top, and there are method constructor as stack of 10 is a constructor which is used to initialize the top values to -1, push and pop and display are the methods. The methods of the abstract data type is classified into three categories. They are constructors, transformers, and observers. What is constructor? Constructors are used to create a new instance of the designated type. So this is called as constructor. Transformers is also used to create a new instance of designated type from one or more instances. So copying will kill. It is also transformers is nothing but constructor also. It is also one type of constructor. Actually, this is called as copy constructor. So we are considering copy constructor. We are constructing new from existing ones. That is called as transformers. Then observers and reporters. By these functions provides information about an instance. So provides data information. So it provides data or information. That's we called as observers. So like this, we construct a abstract data type from existing data types. This is the way of abstract data types. This is about abstract data types. Okay. Is there any doubt? Students can chat if there is any doubt. Okay. Okay, thank you. So we'll meet once again. Tomorrow we will discuss a new topic.